Okay, ladies and gentlemen, let's take a look at doing some hypothesis testing. Now, of course, for your test, you're going to need to be able to use Minitab. Now, you'll be able to use Minitab on any variety of problems. So let's go ahead and take a look at something like this. CBS News report Times Month found that 593 out of 1,106 people with the opinion felt that a major athlete's record should be eliminated if it's found that steroid use was set. Test the claim that more than 50% of people feel this way. There is only one sample. We're dealing with a proportion, so we're going to go to basic statistics, one proportion. Now, in that one proportion, we're going to say summarized data, and our number of events would be 593 out of 1,106. Now, we're going to perform a hypothesis test, and that was 50%, so that's 0.5. Thing we need to remember is, of course, to change our options. Now, in this case, it says more than 50%, so we want to say options greater than. Now, in this particular case, we're going to run this test, and it gives us an exact value of 0.009. Now, do remember, ladies and gentlemen, that unless it says otherwise, we're testing against 0.05. Now, 0.009 is less than 0.05. If it's less than 0.05, it is too rare, which means we would reject HO, giving evidence to support H1 and the claim. So we would say more than 50%. Yes, we reject that it's less than or equal to, meaning it is indeed more than 50%. So that's a one proportion. Now, you could also do a one proportion says test the claim that at least 40%. So that's again going to be stat. It's going to be one proportion. And it's summarized data. And in this case, 161 out of 391. And it says at least 40%. So 40% at least means equal to or greater than. So the alternative to equal to or greater than would indeed be less than. And again, here we go, p-value of 0.70. Now, if it's 0.70, that's way bigger than 0.5. So we would fail to reject HO, so less than. So it'd be greater than or equal to. Greater than or equal to 40% would be acceptable. Now, if we're going to talk about proportions with two groups, that's fine. We can do proportions with two groups. Males and females, test the claim that you are more likely than men to strongly agree with the statement. So that women are more likely than men. So in this case, stat. We have two groups, so it's two proportions. And it's going to be summarized data again. Now, females more than, so that's going to be 200 out of 328. And it's going to be 140 out of 251. Options is test one is more than test two. Okay. So we hit OK. And again, our p-value is what we're looking for, 0.10. 0.10 means we fail to reject HO. If we fail to reject HO, we do not have evidence to support H1. And since our H1 was more likely than men, we can't support that women were more likely than men. The best we can do is retain or fail to reject that they are equal to or less than men. Now, down here, we have a different situation. In this case, we're given N, we're given a mean, we're given a standard deviation. So we have one group, a sample of women in their 30s. So it is one sample. And now, because I have 49, I can go ahead and call it a z-score. But you'll notice because there's means involved, sample size is 49, sample mean 18.374, known standard deviation 3.892. Perform hypothesis test. Now, the hypothesis test is at least 17 years old. So 17 years old. Now, at least means greater than or equal to. So the alternative to greater than or equal to would be less than. So there it is. And here it is. Our p-value is 0.993, which is way bigger than 0.05. And it's also bigger than 0.1, which is what we were also asking. So it says at least 17 years old. So we fail to reject equal to or greater than, meaning we have no evidence to support that it is less than. So it all depends on where that equal to is. Remember, the claim can go in either place. And the only thing the p-value tells you is whether to keep or not keep HO. So we have done one mean, we have done two proportion, we've done one proportion. Let's do a two mean. In this case, Japan versus Mexico, or in this case, wed versus unwed. So let's do wed versus unwed. Stats, basic statistics, two sample T. Now it's because we have two samples. So shockingly enough, summarized data. Sample 1, we have 153 versus 149. We have a mean in the first group of 3349, and we have a mean in the second group of 3392.4. We have a standard deviation of 428.116, and we have 445.602. Now, in this case, we say the sample of white women aged this to this, having single birth gestation period at least 37 weeks, the weights of babies in grams summer. So test the claim that babies born to married is more than unmarried. Now, because I put unmarried in sample 1, if I want married to be more than unmarried, I want to say sample 2 is greater than sample 1, and a p-value of 0.806. And the answer here would be we fail to reject, because that is way bigger than 0.05. We fail to reject HO, meaning there is no evidence to support that it is indeed more than. Okay? No evidence to support more than. In fact, it makes sense that they're going to be equal here. In fact, I could even redo that and say, hey, let's do the same exact test, but let's see if they're equal to each other basically or not. Just like you would do for your semester project. And indeed, p-value of 0.389, that's way bigger than 0.05, so we would retain that they are indeed equal to. Okay, so that is the basics testing with one mean, one proportion, two mean, two proportion. We'll come back in a different video and pick up the advanced tests.